Hello everybody, I'm Roman Rodriguez and we are starting a new chapter today, which is vectors, chapter 5 according to your textbook, and this is physics that we are doing for grade 9 and 10. Right, before I move on to the problem, let me just explain to you about vectors. You know that physical quantities, basically there are two types, scalar and vector quantity. Now scalar quantities are those quantities which have magnitude and they have a number and unit for specification, but it has no direction. No direction. And vector quantities are those quantities which have magnitude with your numbers and unit for specification, and yes, it has direction. Okay. So those physical quantities which have magnitude as well as direction is called vector quantity. Scalar quantities are those quantities which have magnitude but no direction. Example of scalar quantity is like speed, time, then you have volume, mass, and so on and so forth. Whereas vector quantities are those physical quantities like, for example, velocity, you have displacement, then you have force because they have direction, weight, acceleration, so on and so forth. Okay, so uh, our chapter is all about vector quantity. We are not going to discuss scalar quantity, only vector quantity. Now, we need to represent a vector, and vector on paper can be represented by means of an arrow. This is the arrow, if you can see here. Okay, now the length of the arrow tells you the magnitude, and the arrowhead indicates the direction, towards which direction the force is being applied or body is moving with a velocity of certain 70 kilometers per hour, whatever. So the arrowhead indicates the direction and the length of the arrow indicates the magnitude. So it must have a number and unit for its specification. Right? So this is how vector is represented by means of an arrow. And remember, when you are finding the vector, additions of vector, when you are adding two or more than two vectors, then they are always added following the rule of head to tail. Means if you have one vector acting along this direction, let's say from O to A, then it is acting along this direction, A to B, so head to tail, and then B to C, this way head to tail. Okay, so you can see the head of the first vector is joined by the tail of the second vector, and the head of the second is joined by the tail end of the third vector. In the same way, the head of the third vector will be joined by the tail end of the fourth vector, and the resultant of this is this vector. This will give you the resultant, the total. Okay, so in which direction it is pointing to and what is the length, the magnitude of this, that will indicate you, will tell you the resultant of all the vectors. One vector 1, 2, 3 and 4, depending on the size. Okay, so the resultant vector basically, the tail end of the resultant will join with the tail end of the first vector, and the head of the arrowhead of the resultant vector will join with the arrowhead of the last vector. Okay, this is very important to know that. So this is how we add vectors. Okay, later on when we are doing subtraction of vectors and multiplication, then we will be coming across that. But now at the moment you need to know how vector is represented. Okay, right. So as I said that vector, you need magnitude, which means number, and unit for the specification. Okay, and it needs to have the arrowhead indicates the direction. But when you are drawing a vector, you need to know two things. Number one, the scale, and the second thing that you need to know is the direction indicator. Direction indicator are of two types. Direction indicator, the two lines crossing each other which tells you the direction, for example north, south, east and west. Okay, and this direction would be northeast, this would be northwest, and this would give you southeast, and this will give you southwest. Okay, And the other type of direction indicator that we have are two lines crossing each other, one along x-axis, okay, and the other along y-axis. This is the y-axis, okay. So you know the value of x is positive over here, and here x is negative, y is positive over here, and y is negative. So these are the two direction indicators that we use whenever we draw a vector. Okay. Now let's move on to the first question. It says here that draw the representative lines of the following vectors. Number 1, force of 15 Newton making an angle of 60 degrees with x-axis. Force of 15 Newton making an angle of 60 degrees with x-axis. So let's take an appropriate scale. If we take 5 Newton as 1 centimeter, so 15 Newton would mean we'll have to draw a line of 3 centimeters, right? At an angle of 60 degrees with x-axis. Now a direction indicator will show the x and y-axis. This is the x-axis and this here is your y-axis. Okay. So you have to, let me just draw a rough figure first. You'll have to draw 15 Newton making an angle of 60 degrees with the x-axis. So from here you'll have to draw a 60 degrees angle and the length should be 3 centimeter because 5 Newton is equal to 1 centimeter. We are drawing 15 Newton line. So this length should be 3 centimeters because 3 centimeter according to the scale would mean 15 Newton. So for this I just need to have a ruler and a protractor. Okay, I have a ruler and a protractor. I can draw it with the compass also, the angle of 60 degrees, by using a protractor. Now, if I take 5 Newton, 1 centimeter, that means 15 Newton would be 3 centimeters. So I'll be drawing a line of 3 centimeters. So let's say this is 3 centimeters. Okay, first I have to draw the x-axis. This is my x-axis. And at a 60 degree would mean, if I take this, 60 degree would mean here. This is 60 degrees. I will draw a rough line over here. And now if I take this is 60 degrees. And now 15, 3 centimeters, let's say this is 1, 2 and 3. So if this is 3 centimeters, my arrowhead should be here. I'll have to just erase this. Always use a pencil and an eraser when you're drawing. So let's say from point O to A, and this here is 15 Newton. Okay? Because you've drawn a 3 centimeter line, and 3 centimeter, if you convert, take this 1 centimeter is equals to 5 Newton. Centimeter, centimeter cancel, 3 5s are 15 Newton. So there you are. You've got a 15 centimeter line making an angle of 60 degrees with x-axis. Okay? There you are. So this was the first question. Now, second one, it says here, displacement of 60 kilometers in the direction of north. Now for here, you'll have to just write on the scale. And the scale 60 kilometers is it. Scale. So let's say 1 kilometer is equals to 1 centimeter. Oh, sorry, 10 kilometers equals to 1 centimeter. So I'll have to draw a 6 centimeter line in the direction of north. So here we'll use the direction indicator north, south, west and east. Okay. So I'll have to draw a straight line of, let's say this is a horizontal line. I'll draw 90 degrees. Okay, I'll just draw two lines, just making a 90 degrees angle. I'm just drawing a rough figure over here so that you know what exactly I'm doing. Okay, this you know is west, this is east, this is south, north is over here, and I'll be drawing a length of 6 centimeters. So if this is 3, 6 centimeters would be, say, 1, 2, 3, 4, or approximately somewhere around this much. Okay, there we are. Okay, and say 0 to A, and this is in the direction of north, and I will be writing 60 kilometers. Actually, if you measure this, this is 6 centimeters, and 6 centimeters according to the scale, if I take 1 centimeter is 10 kilometers, centimeter cancel, 6 tens are 60 kilometers. Is that clear? So I've got 60 kilometers. Third, velocity of 30 kilometers per hour towards northeast. So again, your scale, and you can say 30 kilometers, so that means again 3 centimeters, so I can just draw, say, 1 kilometer or 10 kilometer per hour is equals to 1 centimeter, so 3 centimeters will mean 30 kilometers towards northeast, and your direction indicator, you know, this is north, south, west and east. So northeast, they have not given you the angle, so you'll have to draw between the two angles, and you can see this is making 90 degrees. So between the two, north and east, the angle, if you divide 90 by 2, you get 45. So we'll have to draw 45 degrees angle. So I'm just drawing a rough figure over here. Okay, let's say this is and here. This is north and this is east. So I have to take 45 degrees over here. 45 degrees would mean this is 45 here. So I'll have to measure 3 centimeters along this line, and 3 centimeter would be somewhere around here. Okay, so yeah, this is 0 to A, and you can see it's exactly in the center, 45 and 45. So this is a velocity of 30 kilometers per hour. So this is 30 kilometers per hour, a 3 centimeter line. If I convert 3 centimeters, taking the scale as 10 kilometers per hour, because 1 centimeter, 3 times 10 will give you 30 kilometers per hour. Okay, so this is how you represent these lines. Okay, vectors by these arrowhead lines, as you say. Okay, I'll be doing the next question in my next lesson. So hope to see you then. Take care.